Welcome to Faith and Science. I'm Dr. John Ashton. I think, when my experience is when we're out in nature and we come across a particularly large wild animal, or we see large wild animals, there's something, really special about, being able to see them. Of course, we see a lot of very small animals in the wild, little ants and grasshoppers and small birds and fish and these sort of things. But don't often see really large wild animals in the wild, just in wild. I mean, we can see some in zoos and this sort of thing. And so I had a really interesting experience while going for a walk with my wife around the foreshore of a lake that is nearby. And as we approached a particular corner where there was a rocky ledge that went out, and it was quite low tide, so we were able to walk out on this rocky ledge a little bit further. I noticed these two fins in the water, but then they went under the water and then they came up again, and they were very close to the shore, like only a couple of metres, 6 feet, 2 metres away from the rocky ledge. So it must have dropped away quite deeply, and went over and realised it was a very large ray. Now, I'm not an expert on observing rays. A friend of mine said it might have been a manta ray, but it was very interesting in that it was just swimming very slowly along. It would have been perhaps 1.5 metres across between the fins going up. So, and maybe the entire width of the ray when it was out flat might have been close to 2 metres, I'm not sure. But anyway, in that order of size, which is quite large. I've seen, lots of smaller stingrays, maybe, 2/3 of a metre across, this sort of size. But to see one that big, but also swimming on the surface so that these two fins, the edges of its flaps, whatever they're called, I've forgotten now, curved upwards and were in the water, and they certainly looked like two shark fins, and then they would go down. And we were able to see this very large animal swimming along, very, very slowly. And I don't know, there was just something, seeing a large animal like that so close, just swimming along and just being able to observe it in the wild, just natural, sort of did something for me. And a little bit further around the lake, a few days later, we were walking along, we saw some quite large, one or two, I can't remember now, nearby, quite large turtles swimming along. And it was a common species of turtle that is found off the coast of New South Wales, Australia. But again, just being able to watch these turtles just feeding and just, again, very close to shore, less than a metre off from the rocky shoreline. I was thinking again too of just recently on the news there was a report of 100 humpback whales that had gathered and were hunting the small fish, big pod of fish, or big school of fish, I suppose, and it was a pod of whales. And the whales were working there. They'd surrounded this school of fish and were herding in, and then they were coming in and feeding. And it was filmed on the news and written up in the newspapers because there was a whale watching tour boat that happened to be right nearby just at the time. And maybe somebody had a drone, or maybe there was a helicopter, but they had aerial footage of it and showing the whales just turning on their side and eating these the fish, just scooping them in and having a big feeding meal, I guess, a banquet, you might say, a whale banquet. And they said there was about 100 whales eating of these humpback whales. And I think whales, I know again when the whales are going past the coast of New South Wales, they're mainly humpback whales, we always enjoy going out and seeing the whales. We see the water spouts at times when they surface, but if they breach, and of course humpback whales are quite famous for breaching, is it's really spectacular, and I think it's just something about that connects, in my view anyway, with the Creator, with an awesome God who could create this amazing diversity of life from, the tiny little krill that, some whales feed on and so forth, these tiny little crustaceans, like little, they're like little what we call prawns, I suppose, but and smaller krill. They're a little multi-segmented little creature that swims around in the water. But the huge amount of food, of course, that these animals would require. And I remember reading, of course, that the blue whale, which again feeds on krill, can grow up to 100 feet long. That'd be over 30 metres, I guess, and weigh 200 tonnes. When you think of that, that's like 100 SUVs, 100 four-wheel drive vehicles in one creature. It's the largest creature that ever lives, apparently larger than any of the dinosaurs. So the blue whale, and they're still alive. They're still there, these giant creatures. And again, the fact that we have so many of these giant creatures still there makes I guess a little bit of a glimpse of what it must have been like living in the time of the dinosaurs. And of course, the evolutionary model doesn't allow for humans living with dinosaurs. But I think when we look at some of the descriptions in the Bible, in Job, and also in Genesis, where it talks about, God creating the great sea monsters and so forth, the evidence is there that there were human-dinosaur interactions. I think the overwhelming number of dragon accounts, dragon stories around the world fit the image of the giant lizards, and particularly in some of the northern countries, Norway and Sweden, as I think I've mentioned before, talking to a scientist when I was visiting one of the universities up there. She was saying there's so much in the folklore of the history of these Scandinavian countries of these giant predator, what they're called dragons or giant monsters that were there. And of course, on one of the islands just up the North Pole, I found quite a well-preserved skeleton of a giant marine reptile and they recovered soft tissue from that. So again, the fact that we find soft tissue in these things just, in my mind, just confirms this picture that these giant creatures did exist. But the largest of all the toothed whales are the sperm whales. And I was reading a very, very interesting article about sperm whales. They're one of the deepest diving animals and in the world. They're as far as I know, in terms of recording, there's a couple of other creatures that I think there's a particular seal that can dive deeper, and I think there's another smaller whale that can dive deeper. But these enormous whales that can reach up to 20 metres in length and weigh about 50 tonnes, 50,000 kilos, they can dive down 1,000 metres. They can dive a kilometre down into the ocean in search of their preferred food, which is squid. And so, when you think about that, being able to dive down that far, and we know, divers get the bends and all this sort of thing if they come up too rapidly. And so the design that enables them to do this, because, when you think a whale, they breathe air, they can't stay down there that long, they've got to come up and rebreathe. And so it's very interested to read about the sperm whales, because I've been interested in them for a long time. You hear the stories about battles between giant squid and sperm whales, although none have ever been observed, but they have found the sucker marks, giant sucker marks on the side of sperm whales that have been captured that obviously showed they had been grasped by a very, very large squid. It's interesting that they can dive a kilometre down into the waters in search of their food, and they search for food day and night, staying down on average apparently 40 to 50 minutes, but sometimes more than 2 hours have actually been recorded, in the order of 138 minutes. And when they surface, they stay up for about 10 minutes to release the carbon dioxide and take in more oxygen. But when you think about it, one of the challenges is, how do these huge animals locate their prey in the dark ocean down there? I mean, a kilometre down is not much light. How do they provide sufficient oxygen for all their tissues when they're down there for so long? And how can they survive those pressures? And also, I've got to think, when you get down a kilometre down, the ocean's pretty cold down there. And so these are some of the reasons that, reading the article about the sperm whale, I was very interested to read about these and to learn. And one of the features of these toothed whales is their capacity to use echolocation to find their prey. Sort of like bats. We hear a lot about echolocation in bats, but the echolocation is the whale's ability to see by emitting the specialised sounds and that way they get a picture of their environment. So as the sound waves bounce off objects in their environment and then come back, as the sound comes back from the distant objects, they can pick the differences, I guess, in the time coming. And the sperm whales actually have special valves along with small sort of bodies of fat that are located in the upper nasal or breathing opening in the sperm whale's head, and these produce the sound, very high frequency sound. The air is forced through these valves and causes them to vibrate in a manner similar to the human vocal cords, but the sound is at a much higher frequency than is heard by humans, this echolocation sound. And then it's actually directionally transmitted towards its prey by the spermaceti organ. And so this is this organ that takes up so much of the sperm whale's head space, and sperm whales' heads, of course, are huge. They actually occupy a third of their body length. This spermaceti organ takes up, is filled with low-density fats that sort of act like a lens. They act like a sound lens, and they produce these short-duration clicks, which is sort of like, ends up being like a buzzing sound as it approaches a prey. And so the whales can actually change the vibration frequency and the time of the vibration and or the interval and the duration. And using this in their brain can interpret those signals as a three-dimensional image. Now, when you think about it, this is really incredible because what we see here is we've got physical structures, right? But the image in the mind of the whale is non-material because it's its thoughts. And, of course, whales have the largest brains on the planet. The blue whale has the largest brain of any animal. And so these whales got giant brains. So when you think about it, producing this image is actually non-material. It's in their thoughts, in their consciousness. And so this really poses a very unique problem for evolution in that we have all these structures that work together, right, that generate the sound, that are enabled to be focused and so forth, to produce an image that's interpreted by the whale's brain in his mind, and he can then picture an image. Much the same as when we look at an object through our eyes, we form an image. That image in our brain is non-material, it's in our mind. And these are major problems. Consciousness is a major problem, but the eye, and as I said, this echolocation device in a sperm whale, the fact that we have physical organs that coordinate together then to produce an image, and if they're not all there, it's not going to work, right? It's not going to produce an image. The whale's not going to be able to hunt and provide. It's powerful evidence that the whole thing had to be created at once and designed. Now, one of the other aspects in sperm whales is that the sound is not directed into the middle ear through the ear canal as it is in humans, but through highly sensitive fat tissue, which is actually located in the jaw. And then the sound's conducted to the inner ear. And this is via an organ called the tympanic bulla, which is suspended by connective tissue in a mixture of fat and air that actually separates the middle ear from the skull and thereby focuses the sound waves to enhance reception. So again, we've got this special sound focusing device or mechanism within the whale to concentrate the reflected sound back for the image. And this membrane is reinforced with bony ligaments that again improved hearing, particularly at high frequencies. So we have here a totally coordinated system both in emitting sounds and also in receiving the sounds and producing that picture. I guess one of the other things is the breath-holding sperm whales have a number of physiological mechanisms to counteract the compression and subsequent damage that would result to tissues from the huge hydrostatic pressure when diving down. So I'm just trying to think one atmosphere of water is 34 feet, so that'd be, say, 11 metres, something like that. So if we go down, a kilometre, we're looking at almost 100 atmospheres pressure. Around that order, it might be 90 atmospheres of pressure if my calculation is correct. That's a massive pressure. And if we look at 15 pounds per square inch, well, so, you're looking at something like 14 or 1,500 pounds per square inch pressure. And so this enormous pressure on the whale there would, just compress things. But it's interesting, in order for this not to occur, the pressure within the body, with any air spaces within the body must match that of the ambient pressure, so to avoid any distortion or crushing. And so it's quite fascinating that as the whale dives, the air-filled cranial sinuses and so forth in the head there become engorged. So they sort of swell up and squash out the air. So they eliminate the air so as to prevent a sinus squeeze. And the other thing is the airways, the peripheral airways in the sperm whale are especially reinforced. And this allows for a gradual collapse of the lungs with their air being pushed into the upper airways, and actually stops the exchange of gases in the blood. And so this eliminates or greatly reduces the risk of the whale getting the Benz type philometer, because limiting this gas exchange reduces the nitrogen absorption, and hence prevents nitrogen narcosis. So, and it's interesting that the lungs of sperm whales only store about 5% of their total oxygen, and so they're actually not considered as important for the oxygen store. Instead, the actual oxygen is stored in the blood of the whale. So whales have a very large amount of blood in their tissues, about 200 to 250 mils per kilogram of tissue, and this acts as a huge oxygen store. Now, I know, I have great problems holding my breath for any length of time underwater. I'm amazed when I see these people who can hold their breath for 4 minutes and this sort of thing, divers. But it's very interesting in the whale itself. It's not relying on that oxygen stored in their lungs as I would be, but instead they have a very large blood supply, and this blood has the capacity to store large amounts of oxygen. And one of the reasons it can store this extra amount is that the blood in the sperm whale has much higher levels of the oxygen-binding proteins, hemoglobin and myoglobulin in the blood and in the muscles and so forth. So again, it has much higher levels of these particular oxygen-binding proteins. So again, this all points to design. For evolutionists to propose that, and they reckon a lot of these whales and that were land-dwelling mammals that returned to the sea. Some of the stories, when you think about it, they just lack common sense. And for the DNA code to deliberately then start changing so it makes higher levels, higher concentrations of these particular special proteins so that the whale can survive underwater. What's the random chances of that happening? Because it's got to be just a random mutation. And when we look at all these design features, we can see random mutations aren't going to generate these systems that work together. And without them, the whale's not going to work. It's not going to be able to dive and all this sort of thing. The other fascinating thing is that sperm whales can also reduce their oxygen use and energy consumption by slowing down their heart rate and metabolic rate when they dive. And again, so they have the mechanism, so I guess it just becomes an automatic control mechanism that slows this down. As they're diving, of course, they use less energy because they can just fall down. And their streamlined torpedo-like body, of course, it's amazing shape. And you look at them, a lot of torpedoes were designed after that shape. Along with extensive use of gliding, provides minimum drag and reduced workload for the muscles. So it's amazing. Now, another aspect, of course, is the ability to maintain body core temperature. This is another essential physiological mechanism of a warm-blooded sperm whale, and they're going into this really cold environment. And water, of course, is a very good conductor of heat. That's why we use it in our automobile radiators. But they have blubber, again, which can be up to 250 millimetre thick, and particularly around the whale's organs provides this insulation. Also, they have a low body surface to volume ratio that reduces heat loss. But what about their flukes and flippers? They're very thin. and they don't have much blubber. And to overcome this, the whales have a special countercurrent system which involves arteries and veins that run parallel but in opposite direction. The cool incoming venous blood from the flukes and flippers that are exposed to the cold water is warmed by the outgoing arterial blood from the heart, forming an efficient heat transfer mechanism. Isn't that amazing? And conversely, when under heat stress, whales have a superficial venous system in their skin that is not warmed by outgoing arterial blood and thus enables the whale to cool down. You know, when you think about it, sperm whales are amazingly designed for foraging and living in deep ocean waters. And, if you remove any of those interconnected mechanisms, it would affect their ability to survive down there. And really, it's amazing evidence of a super intelligent designer creator. You know, when we look at so many things in nature, we have overwhelming evidence of supernatural design, super intelligent design that was able to not only design the whole concept, but then was able to make a genetic code, the DNA code, that could encode this information and then make micro machines that could read that code and translate it and actually build the organism. When you think it, whales start off as a little cell. The male and female gamete cells combine, they form that little cell that grows and multiplies and builds. That mechanism, that whole whale is built that way and powered by metabolic processes and energy to build that whale to that design. You know, the whole thing just points of an amazing creator. We have an amazing, awesome God that has said that one day he's coming again and he's going to recreate all the people that have believed in him again, alive, make them alive at the second coming of Jesus. You know, when we see this design, that is a very believable statement that the guy who created this system, the God who did that, can recreate us if we have died, and if we're alive, recreate us with perfect bodies. And that's the hope that the Christians have. That's the story that the Bible has of a God who created us, of sin and things went wrong, and he wants to recreate us to live with him perfectly in a wonderful life again. You know, you've been listening to Faith and Science. I'm Dr. John Ashton. If you want to re-listen to these programs, remember you can Google 3ABN Australia, or one word, .org.au, and click on the listen button. Have a great day.
You've been listening to a production of 3ABN Australia Radio.